photo. Now what happened was...
Now what happened was the circuit breaker popped. Okay, this may happen when you're back here. We put in some work orders for this, but they haven't been fixed yet. But the machine may pop a breaker. It popped immediately as the light came on. That's okay, because now I'm going to do the full 20 unit exposure. If it happens partially through your exposure time, you're going to have to subtract the amount of seconds, or not seconds, but units of light that were exposed from 20 to get your additional exposure time. So here comes the light on. And I'd say it sounds kind of like a bug zapper, where you hear that kind of clicking sound and the light slowly coming on. If we look down by the bottom of the machine, this is called a bellows, and this bellows is preventing light from hitting our screens that are coated. But you can see the light start to emanate from those little ventilation ports in our bellows. Okay. Now, if I come back over to the timer, you're going to see that we're only on 18 on our timer. This light exposure is not done through seconds. It's done through what we call light units. This exposure unit has what's called a light integrator in it. So a light integrator measures the amount of light that is being cast on our object from the bulb. So we know a light bulb gets weaker and weaker as it's being used. The amount of light it's throwing off actually gets weaker and weaker. We need this amount of light to stay the same all the time, no matter whether our bulb's brand new or whether it's 3 years old. So the light integrator gives us that same amount of time no matter what or how intense the light is. So the light exposure is done. Our timer says EC3. I'm going to turn the vacuum off, okay, and I'm going to hit the reset button so it's set back to program 320 units for our next person. Now we're going to unlatch the vacuum blanket, let that lift up. I'm just going to pull the screen out, and now a molecular change has happened, okay, to this screen. The light has gone through the clear areas of our film positive and exposed the emulsion. When white light hits the emulsion, something called cross-linking of the molecules happens. A cross-linking of the molecular structure of the emulsion makes that emulsion coating now water resistant. When I peel off the film positive, we're not going to see any difference really, but the areas that are black on our film positive have prevented light from going through and reaching the emulsion. So that emulsion is still unchanged. The molecular structure hasn't changed, and if you remember from when we were earlier on in the demo, we said unexposed emulsion will wash out with water, okay, or be water soluble. So I'm going to take the positive off and we say, wow, what's on there? Well, what we have is what's called a latent image, L-A-T-E-N-T. The image is there, but we have to develop it. Now this is a photographic process, old school photographic process, that, you know, if you talk to your parents about it, when they were kids, they had film that they loaded up in a camera, and you had to take that film and keep it in a light tight cassette, take it to a camera store or a photo booth, and they sent that out and developed it with special chemicals, and then they made photographic prints. So this is similar to that process, but not as complicated in terms of chemistry and things we need to develop. So that's your exposure process. And from here, we're going to take a little break and then go show you how to develop this stencil image.